19th question. This topic has been brought from Principle of Communication, and this is another chapter which is specially reserved for JEE Main. It does not exist in the advanced syllabus. And even in the previous questions, those exclusive chapters of JEE Mains, I have very categorically stressed upon the fact. So will I again. These are the topics one has to be very careful if someone is preparing the JEE Main. And the topics and the questions are very straightforward. It's a AM circuit. This is the carrier signal. This is the message signal. We need to calculate the value of modulation index. So some people denote by mu, some denote by small m, whatsoever is your convenience. The modulation index is the ratio of amplitude of message signal to that of carrier signal. So 2 by 4, that's going to be 0.5. And it asks the lower sideband frequency, which is FC minus FM. The upper sideband, FC plus FM, right? So FC minus FM, well, this is very clear, 10,000 and this is 1,000, the frequency. The difference is going to be 9,000 hertz, that will be 9 kilohertz. So option number 4 is there, ready, waiting to be ticked. That is the correct option for 19th question. Let's go for the 20th. 20th question, another straightforward one, and that is from the magnetic field. So by uses of the Biot-Savart law, you'll be solving it. There is a current carrying wire and the length is 6 centimeter and it carries a current 5 ampere. And we need to calculate the magnitude of the magnetic field at this point. Well, this is 5, this is 3, that means this has to be 4 centimeter, right? And now to calculate the magnetic field due to this at this point, I think that's a very straightforward one. Let's put it though, and that's going to be mu naught I divided by 4 pi r. This r is of course 4 centimeter, put the unit, into sine alpha plus sine beta, and sine alpha, sine beta both are same, and which is equal to 3 by 5. So that's going to be sine alpha plus sine beta 6 by 5. That much is the magnetic field at that given point P. Put the value, get the answer, and yes, 1.5 into 10 raised to the power minus 5. This would be the correct option, option number 2. Let's now go into the last 10 question. Let's proceed to 21st question. 21st question, modern physics, the fertile part that I had said. And we need to see a hydrogen atom revolving in its second excited state, n equals to 3. Be very careful. And the radius is of course 4.65 angstrom. The third orbit radius has been given. We need to calculate the de Broglie wavelength of this electron, and the de Broglie wavelength for this electron would be given by this simple expression, 2 pi r equals to n lambda. So yes, r is there, 4.65, n is there, which is 3. Whatever comes the value of lambda, that would be the de Broglie wavelength. 9.7 angstrom is waiting to be ticked. Option number 3 is the correct for 21st question. Let's move to 22nd question now.